Okay, students, continue with our next topic in this chapter, that is ions. What are ions? The charged atoms, we can say, or charged species are known as ions. Any kind of species, atom we have, or molecules we have, when there's a charge on that, then that is known as an ion. So, the definition of ions is the charged species are known as. Species covers every type of particle, whether that is, you can say, atom, that is compound, molecule, all these particles together we can use a term species. So the charged species are known as ions, and these ions we can divide them further. Like if there's only one type of atom in that, like we can say consists of, if this ion is consisting of a single charged atom, just single charged atom is there, then that is known as monoatomic ion. Mono means one, atomic means atom. So one atom, if it is there and that has a charge on it, that is called monoatomic ion. Next is if it consists of a group of atoms having charge on them. If there are a group of atoms and there is a charge on them, then that ion is known as polyatomic ion. Ion means charge, poly means many, atomic means atoms. When many atoms they will have a charge on them, then that is known as polyatomic ion. So another way to classify these ions is based on which kind of charge is there on these. It's positive charge or it is a negative charge. So ions carries, an ion carries positive or negative charge. Positive charged ions are known as cations and negatively charged ions are known as anions. Positively charged ion is called a cation. And if there is negative charge on these ions, negatively charged ion is called an anion. Then we call that ion as an anion. So we are taking some examples now of monatomic, polyatomic, cation and anion examples, and this table you have to learn because this is required for the next topic also. So names and symbols of some ions. First is name of ion. What is the name of this ion? And what is a symbol? Symbol means with the charge. First is sodium. If we have an ion formed from sodium, there is one positive charge on this. Its symbol is Na plus. Potassium is K. This is K plus. Similarly, silver, it's Ag plus. Copper, in bracket in Roman number I am writing 1 here. This I'll explain it to you afterwards. What is this 1 here in Roman number? This is Cu plus. That means these all ions, they have one positive charge on them. And these are just made up of one atom of sodium, one atom of potassium, one of silver, one of copper. So these are which kind of ions? These are monoatomic ions. And they all carry positive charge. That means these are cations also. Monoatomic plus these are examples of cations. Next, after this, we have another example, magnesium, then calcium, zinc, iron, and in bracket here I am writing 2. Then copper, I am writing 2. Here copper is 1, here copper I am writing as 2. Now you will come to know the difference in the two. It's Mg2 plus, there's two positive charge here. Calcium is also Ca2 plus, zinc is also Zn2 plus, iron is Fe2 plus, copper is Cu2 plus. So we can have the copper ion with +1 charge and the copper ion with a 2 plus charge also. So that is why these numbers are written here in a bracket here in parenthesis. That shows that this copper is with +1 charge or this is with the 2 plus charge. So that is why these are written here. Next one after this, some more examples. Aluminium. Now here also I am taking iron, but in bracket now I am writing 3 here, not 2. Here we are written 2, here I am writing 3. This means this is Al3 plus, 3 positive charge, and this Fe is with 3 plus charge on it. So iron also can have 2 plus charge or 3 plus charge. Next, these all are the examples of cations I have taken, and all these are monoatomic ions. Now, some more examples where I am taking the negatively charged ions, but all these will be monatomic only. So, first we are covering up the monatomic only, cation and anion, and then we will do the examples of polyatomic ions. So, next example here after ion is hydrogen. Then I am taking hydride, chloride, bromide, iodide. All these are negatively charged ions, and there is 1 plus charge here on this hydrogen. But hydride is again H only, but this one has minus charge. That is why these two are written together, so that you can see the difference in the two. Hydrogen with plus charge is called hydrogen ion, and with minus charge is known as hydride ion. Chloride is Cl minus, bromide is Br minus, iodide is I minus. So these are examples of -1 charge. That is, these are anions and made up of 1 atom. So these are monoatomic ions. Monatomic and plus these are anions. Oxide, negatively charged ion with 2 minus charge. Then we will do the example of sulfide. This also has 2 minus charge. So again these are anions and these are monoatomic ions. Next example is of nitride. Nitride is N3 minus. Nitride N3 minus. So we have covered up anions and cations, but monoatomic we have covered up. Now I am taking up the examples of polyatomic ions, where we will have more than 1 atom and their symbols. So we will have cation and plus we will have anions in this polyatomic and symbols of these. Like if we take ammonium, only 1 positively charged polyatomic ion we are learning here, that is ammonium. Remember, ammonium is NH4 plus. Some students they write this as NH3 ammonia. Ammonia is a molecule, is neutral, while ammonium is a cation, polyatomic cation. Next is hydroxide. OH, made up of oxygen element and hydrogen. This is made up of nitrogen and 4 hydrogen atoms. That is why it is polyatomic. Many atoms are here. This is made up of 2 type of atoms, so it's polyatomic. Next is nitrate. Nitrate is NO3 and there's minus charge here. Then hydrogen carbonate. Hydrogen carbonate. Hydrogen carbonate is HCO3 minus. We have atoms of hydrogen, carbon and oxygen in this. Next example is of carbonate. This is sulfite, ITE, sulfite, and then is sulfate. Carbonate is CO3 and there's 2 minus charge. Sulfite is SO3, 2 minus charge, and sulfate is SO4, 2 minus charge is there on this. Next we are doing phosphate. Last example, phosphate is PO4 3 minus. PO4 3 minus. So these are examples that we have to learn. Now some elements show more than one valency. Some elements show, there's a note here. Some elements show more than one valency. For these elements which show more than one valency, a Roman number, a Roman numeral we are using shows their valency in a bracket. So now there's a new term here, valency. Valency I'll explain after this. But this is Roman numeral that we are using. See here, this Roman numeral that is used here. What is this Roman numeral? This shows the valency in a bracket, that this copper is with one valency, this copper is with two valency, this iron is with two valency, and this iron is with three valency. That means these elements, they show more than one valency. They show more than one valency. Now we're coming to this part, what is actually a valency. So first we have covered up ions. So what are ions? Charged species or charged particles are called ions, and these can be monoatomic or these can be polyatomic, or we can also divide them as cations and anions. And some examples we have to do of cations and anions, of monatomic ions and polyatomic ions. Moving on to the next topic, that is the valency now. So what is valency? Valency, we say, is combining capacity of an element. Combining capacity of an element is known as its valency. So this valency actually is used when the element is combining with the other elements. Then how many electrons it can use to combine with these other elements, that is called its valency. So valency can be used to find out how the atoms of an element, atoms of an element will combine with the atoms, or the atom with the atom or atoms of another element. So when one element is combining with the atoms of another element, then we will use these valencies, and as a result of this, a chemical compound will form. For example, if you have to combine hydrogen element atoms with oxygen element atoms, we write the formula as H2O. Why we write the formula as H2O? That formula that we are forming, that compound that we are forming, in that this valency will help us. So valency normally is a charge that we have done just now on the ions. That charge written on these ions, mostly that is the valency only. So that charge when you learn, that is the valency of these elements. So now using these valencies, we have to find out the next topic, that is writing chemical formulae. Using these valencies, we can write the chemical formulae of compounds. Writing chemical formulae. But there are some rules for writing chemical formulas. These rules, first of all, I am writing, but these will be clear to you only when I will take the examples of these. So first is rules that we follow. While writing a chemical formula are as follows. First rule here is the valencies, or I'm calling these valencies now as charges, because I told you the charge which is there on the ion is valency only. So the valencies or charges on the ion must balance when we write the formula. So no charge should be left when we are forming the compound. Positive and negative charge, they should be equal. That means compound should be neutral. Next point is, when a compound is formed between a metal and a non-metal, remember, when we are forming a compound using a metal and a non-metal, these compounds actually are known as ionic compounds. I'm writing here. These actually are called which kind of compounds? Ionic compounds. There are ions here, positive and negative. Then see what we have to do. The name or symbol, whatever we are using, name or symbol of the metal we have to write first. Metal is written first. And non-metal, of course, will be afterwards. For example, if we'll take calcium oxide. See, we are writing calcium first and then we are writing oxide. Calcium is a metal and oxide, oxygen, is a non-metal. And see the formula, even in formula, symbol of metal will come first, calcium, and then will be of a non-metal. So whenever we are writing the ionic compound which is formed between the metal and a non-metal, we always have to write the metal name as well as its symbol first of all, and then will be of the non-metals. Next rule after this, the second rule, third rule. Now, the third rule is, in compounds formed with polyatomic ions, if we use some polyatomic ion like hydroxide, sulfate or carbonate, for example, when we are using, formed with polyatomic ions, the number of ions present in a compound, is indicated, if more than one is there, it is indicated by enclosing the formula. That formula we will enclose in a bracket of that ion, of that polyatomic ion, in a bracket. And outside the bracket we write how many number of ions are there. That is, we just write the number outside. Writing the number of ions outside the bracket. Now, example to understand this thing. For example, if we'll take magnesium hydroxide, we write Mg. Now, polyatomic ion OH, hydroxide is there. But when we write the formula, there are two OH. So what we do is, we write this formula in a bracket of this ion, and outside bracket we write the number that how many of these ions are there. So OH, how many of OH ions are here in this formula? 2. So for polyatomic ions, if more than one ions are there, then we write the symbol in a bracket, and outside the bracket we write how many ions are there. But if there are, for example, only one polyatomic ion is there, then there's no need to put a bracket. In case the number of polyatomic ion is 1, if it's just 1 in number, then the bracket is not required. Bracket is not required. We never write OH whole twice 1. So if we are not putting a bracket, that means it's 1 only. Bracket is not required. For example, for this also, one example to understand this, like sodium hydroxide, NaOH. There's only one polyatomic ion. So there's no need to put this in a bracket and outside the bracket write 1. Just leave it like this only. This is the formula of this sodium hydroxide. So after these rules, now some examples that how we write the formula of these compounds. So first is formulae of simple compounds. For some simple examples we will take. In simple compounds we means the compound that is binary. Binary compound means there will be two different elements in this. So those examples we are taking first of all. The simplest compound which are made up of two different elements are called binary compounds. These are called binary compounds. So now comes the formula, how we will write the formula. While writing the chemical formulae, when we write the chemical formulae of such compounds, we write the constituent elements. Constituent elements means the elements of which this compound is made up of. So, and their valencies. See how we'll write this thing. As shown below, we'll write it. One example. We'll take examples to understand this thing. First of all, for example, we have to write the formula of hydrogen chloride. Hydrogen chloride here. It's made up of non-metal and non-metal, not of metal and non-metal. So in this case, from the name only, whichever element is coming first, you write a symbol of that first and then the next element. See the first step, write the symbol of these elements, hydrogen and Cl. Next step is write valency. See what is written while writing the chemical formula. When we are writing chemical formula of compounds, we write the constituent elements. Hydrogen chloride is made up of which elements? Hydrogen and chlorine. So the constituent elements we write first of all, their symbols we write first of all, and their valencies. Now how we write in a valency? See, we should know hydrogen valency is 1 and Cl is 1. Remember, we write hydrogen as H plus and Cl as -1 in that ions table. So that table we should know, then only we can write these valencies. After writing these valencies, now what we have to do? Then we must cross over the valencies to get the formula of the compound. To get the formula. So now see here, cross over these valencies. This crossover means this one will come with H and this one will go with a Cl. But one we never mention. Formula of this compound will become, write formula of the compound H and Cl. These will come as a subscript here, but 1 and 1 we never write. So formula of this compound is HCl. This is how we write the formula of these compounds. So what we need for writing the chemical formula, we should know the constituent elements from the name, write their symbols, and just we should know their valencies only. Then just cross over the valencies, we will get the formula of the compound. Some more examples to understand this topic, that how we have to write the formula. Second example. Formula of hydrogen sulfide. Then next I will take formula of carbon tetrachloride. Next is formula of magnesium chloride. Magnesium chloride. So now here, formula of hydrogen sulfide. See the name carefully and find out which constituent elements are there which are forming this hydrogen sulfide. Hydrogen sulfide. Hydrogen means H. So first we write here symbol. Hydrogen H. Sulfide is from sulfur. So sulfur symbol is S. Then we have to write the valency. Hydrogen valency is 1 and for sulfide we write 2 minus. That means it's 2. Just cross over the valencies and next what we write is formula. So 2 will go with H as subscript here, H2, and 1 will come with a sulfur S, but 1 we don't write. So formula of hydrogen sulfide is H2S. Next is formula of carbon tetrachloride. Tetra is a number only. So otherwise elements are carbon and chloride. Chloride means chlorine. Symbol of these constituent elements, carbon C, chloride is Cl. Next is their valency. Carbon valency is, we should know this thing, carbon valency is 4. Because this was not in the tables, but we should know carbon valency is 4. Cl is 1. Cross over these valencies and now write the formula. C and 4 will go with this CCl4. That is why it is called carbon tetrachloride, because there are 4 Cl here in the formula. Next, this one now. Magnesium chloride. There's a little difference here now in this example. The first 3 examples that I've taken, these were of the compounds which were made between the non-metal and non-metal. But now it is magnesium, metal, chloride, chlorine, non-metal. So symbol, first of all, we are writing. No change in this. First of all, Mg and Cl we written. Now here in place of valency, we are writing a word charge here. Whenever we will have a compound formed between a metal and a non-metal, in place of valency, we will write a word charge. Magnesium, valency. Valency only is a charge. It's 2. But now the thing is, it's charge. So we have to write a charge here. Is plus or is minus. And this one is -1. Now we'll cross over this thing and we'll form the formula. So this is the only difference. In place of valency, we write a word charge. And in front of that valency, we'll mention a charge plus or minus. Actually, metals, they always form positive ions. Non-metals, they always form negative ions. Cross over this thing. These charges are just for writing only. So see the formula Mg1 and this 2 will go with the Cl. So it's Cl2, MgCl2. So charges here are just for writing only. Otherwise, the method of forming the formula will remain the same only. So now next question here. Next example. Formula of aluminium oxide. Aluminium oxide. So for aluminium oxide, we are using the symbols. Again, it is metal and non-metal. So we write a word charge here. And then we will write the formula. Aluminium Al oxide is O, charge is here 3 plus and oxide is 2 minus. Cross over these. So when we cross over, Al will become 2 and oxygen will become 3. So it is Al2O3. This is the formula of aluminium oxide. Next now, example, calcium oxide. Symbol, charge and formula. Which elements we have here? Calcium and oxide, calcium and oxygen. Charge is 2 plus of calcium, oxide is 2 minus. But if we can simplify these charges, we have to simplify. Even the valency, if we can simplify these, we have to simplify. After simplifying these, then we have to cross over these. And formula will become CaO. So remember this thing, if we can simplify the charges of valencies, we have to simplify. Okay, because formula is always in a simplified form. Okay, we simplify the formula. Next example, sodium nitrate. Symbol of sodium and nitrate. Now see here, we are taking nitrate, polyatomic ion here. Sodium is Na. Nitrate is made up of nitrogen and oxygen, NO3. And the charge here is 1 plus. Nitrate is, we write NO3 minus 1. So it is 1 minus here. So this is the charge formula. Cross over these. Since it is 1 1 only, that means just combine these and the formula will become NaNO3. Next example. Formula of calcium hydroxide. Symbol of calcium and hydroxide, again polyatomic ion here. Symbol, charge, and then is formula. Calcium is Ca, hydroxide is OH. Calcium is 2 plus and hydroxide is OH minus 1, so 1 minus. Now we'll cross over these charges. Ca will be 1 while OH will be 2. Since it is polyatomic ion and how many number? 2 in number. That means what we'll do? We'll put this in a bracket and outside bracket here we write 2 because they are how many number? 2 in number. So this is how we write the formula of calcium hydroxide. So this thing we have to note down here in case of polyatomic ions. How we write the formula? Note, calcium hydroxide is, we have written this as CaOH whole twice and not as, like generally some students what they do is they write 2 here OH and after this they write 2. They don't put this thing in a bracket and outside bracket they write 2. Just with the H only, here with H only they write 2 and not, it should not be written like this. Okay, so we use brackets when we have 2 or more of the same ions, like here in this case is 2 or more ions of same type, polyatomic are there, same ions in the formula. Here the bracket around OH with a subscript 2, bracket around OH and outside bracket as subscript we are writing 2. This indicates, what this indicates? This indicates that there are 2 hydroxyl ions, that there are 2 hydroxyl. So it's complete, hydroxyl is complete OH, hydroxyl group, which is joined with, it is joined with only 1 calcium atom, joined with 1 calcium atom. That is why we have to write it in a bracket and outside bracket we write 2. If you write just like this, this shows that O is 1 only while H are 2 in number. This is means OH is double, OH is twice, so it should be in a bracket and outside bracket we write 2. So more examples of this type. Formula of sodium carbonate. Sodium carbonate. So symbols here. Sodium is Na, carbonate is CO3. Now we write charge. Sodium is 1 plus while carbonate is 2 minus. Carbonate is how much? It is 2 minus here. Now after this formula, cross over these. When we cross over, see 2 will come with Na, Na will be 2 and CO3, this is polyatomic, so but this is 1 in number, so there's no need to put bracket here, just write CO3. If it will be 2 here or 3, then we put this in a bracket and outside bracket only as a subscript will write the number. So in this example, there's no need to put a bracket. In this example, bracket is not required. Why it is not required? Because only 1 ion is there. Because only 1 ion is present. Next example, last example. Formula of ammonium sulfate. Now both here cation and anion are polyatomic. Ammonium sulfate. So first we write the formula, then charge, and then first we write symbol, then charge, and then I'm writing the word formula. Ammonium is NH4, sulfate is SO4, charge on ammonium is 1 plus, sulfate is 2 minus. Now we cross over these charges and the formula we write as NH4 is twice now, so it's polyatomic. That means we will put this in a bracket. Outside bracket here as subscript we write 2. Then 1 will go with sulfate, so 1 we don't write. It becomes NH4 whole twice SO4. This is read as NH4 whole twice SO4. So these are the examples that how we can write the formula of the compound. For homework, I am giving a question. Write down the formula of these compounds. Sodium oxide, just practice these. Aluminium chloride, sodium sulfide, magnesium hydroxide. This is the first question. Second question is we have to write down the names of the compounds. I am writing the formula and you are supposed to write their name. So I am not speaking these because that will be an answer only. This formula written, you have to tell the name of this compound. So you should know how to read these. Write down the names of the compounds represented by the following formula. Okay, so these are the questions for homework.